All right, so as far as our learning of programming in C# is concerned, now you guys have a very good idea of the basic OOP, right? So everybody feels comfortable with encapsulation, creating classes, inheritance, and polymorphism. And we discussed a few categories of it, for example, overloading, overriding, right? Overloading is within the same class, so within same class. Overriding is between base and derived class, correct? Okay, so then overloading further went into a subcategory, operator overloading, and once arrays or collections are involved, then we had the indexers, right? Okay, so anyway, after learning indexers, the whole idea of the indexers was to make the search process on behalf of the client as easy as possible, okay? To give you an example, okay, suppose you created a class called matrix. So suppose you have a class called matrix, right? A matrix is a two-dimensional structure. So in C# you will declare it, for example, double. Okay, because it's two-dimensional, this is how we create a two-dimensional array. Left square bracket, comma, right square bracket, that means it will be a two-dimensional array. Okay, and suppose you can call it data equal to new double, okay, for example, 10 comma 10. If you wanted a 10 by 10 matrix, or you can say null and through the constructor provide how many rows, how many columns will somebody create, right? Or let me just make it a little more flexible. So if I say null, and then if I provide a constructor, public matrix, the default constructor can do data equal to new double, let's say 100 by 100. So that will be the default. But we can also provide a constructor. We can say in rows, in columns, okay? And we can say data equal to new double of rows, comma, columns, correct? Okay, so this would be one way of writing it, right? And also pretend we exposed this as a public property. So we did public double data, and we said get return data, and we said set data equal to value. So let's pretend we also have the corresponding public property for our matrix, right? Okay, so now if somebody created let's say in one of the button handlers, so somewhere over here, so somebody wanted to create a matrix, right? So they will do something like this, matrix M1 equal to new matrix, and suppose they wanted a 10 by 10 matrix, right? So they will just simply call it like this, 10 comma 10, correct? Now, how will they store the data, let's say in row 0, column 0? What will the user say? M1 dot see, we wanted to store something in row 0, column 0 location, right? Data is the two-dimensional array where we store. So somebody will have to say M1, and this is outside the class, so they'll have to go through the public property double, correct? So they will have to say M1 of data, for example, 3, 5 equal to whatever, 22. Okay, and they'll be able to access it. Okay. However, that sort of looks not so clean. Wouldn't it be nice if somebody, rather than writing this, they can simply say M1 of 3, 5, because M1 is the matrix. Okay, so we should be able to directly index the matrix. Okay, the only way we can do that is if we go to the class matrix and define an indexer. Okay, so what will our indexer look like? Okay, so now let's go to the matrix class and define an indexer. So if you remember, the indexers are written like a property. Okay, so if we are allowing somebody to write it like this, okay, first let me take the easy part first. So suppose we wanted to say D double, let's say, something A equal to M1 of 3, 5. Okay, so we are triggering the indexer. What kind of data will it return? Actually, it will return the a double, right? So you will say public double this, and in the square bracket, let's say intro, comma, end column, right? So this means through, we can directly type M1 and we'll be able to access one of the fields over here, right? So anyway, so there is a get part in the indexer, there's a set part in the indexer. Okay, so we can simply say our array is called data, so data of, so we can simply say return data of row, comma, column. Okay, so take a look over here. Get is always triggered when something appears on the right side of an expression, right? Because we are trying to read something from it. So in this case, this will 3 will correspond to the row, 5 will correspond to the column. So it will end up going and returning whatever was stored at M1 of 3, 5. Okay. So once we have the indexer, then there's no need for writing something like M1 dot data equal to, we can directly write it like this. So now let's go to the set part. So what will the set part do? Set part will simply do data of row, comma, column equal to value. Okay, so anyway, let me see, the only, okay, once I go to the computer, I can verify this, whether this should be double or whether this should be matrix. Public matrix, let me see. Row, column. Okay, I'll go to the computer and verify that in a few minutes, but anyway. So, bottom line I was trying to make is that indexers, once we have written them, make our, especially when arrays or collections are involved, they make our access very intuitive, so that you don't have to keep saying dot and then something, right? Further, like we talked about the university class, so remember we had something like this, class student, Okay, suppose we have those 5 fields over here, right? Suppose we have a class called university. Okay, and suppose the university contains a collection of students. So suppose we have array list, let's say st list equal to new array list. Okay, and then in the constructor, let's pretend, okay, in the constructor, let's pretend we create several students. So we say student S1 equal to new student, and whatever data, initial data we put, and then we say st list dot add S1, right? And so on, st list dot add. So let's pretend we add, 5, 10, 100, whatever, however many students to our st list, okay? In real life, we'll read it from the database and then populate it with the whatever data we find in the students table, right? Okay, so once we have already stored something in st list, okay, same thing. What if we wanted to provide a capability, let's say to search for. Okay, so for search for a particular student, right? So our code will typically look like, so suppose we wanted int ID equal to 1, 2, 3, 5, 7, right? Whatever the ID is. And we wanted to know what's the detail of this particular student in our university class, okay? So if we did not write an indexer, then this is how our code will look like. Okay, and suppose there's a public property, so that, let me make it lowercase st list, and the public property will give us the capital st list corresponding to this field, right? So our code might look something like this. If we have already created a university object equal to new university. Okay, so anyway, then in the button handler, so pretend this was somewhere inside of our class form 1. Okay, so in the button handler where we wanted to do the search, our code will look something like this. Suppose this is the student we wanted to search for, so we will say for, there's a couple of ways of doing it. One possibility is, we say student st found equal to null, and then for each student st in u1 dot st list. So through the u1 object, which is our university object, we will loop through this st list, right? And then we will say if st dot whatever student ID, or let's pretend our field is called ID, st dot ID equal to ID. So this is the ID that we are searching for, right? Then we will say st found equal to st and break out of the loop, right? So this will be our typical code. And then we will check if st found not equal to null, and then display the message or display the student information. So st found dot toString. Otherwise, if we did not find it, we can simply say it doesn't exist. Else message box dot show not found. Right? Okay, so anyway, so this is what our typical code will be if we did not write the indexer in the university class. So as we had discussed in one of our previous lectures, if you were only doing it one time, it's okay to write this type of code. Don't create an indexer. But if there were many places in your application you wanted to search for a student, sometimes by ID, sometimes by last name, then it's a good practice to move all the search code to inside the class to make the user's life as easy as possible, so that the user does not have to write all of this code. The user simply writes some code like this to find out if the student exists or not, right? Okay, so the only way we can do that is create an indexer inside the university class, right? So what will our indexer look like? We did that some time ago. Let me quickly refresh your memory. So it will be public student, because once we index, we will get the whole student object, right? And then this int ID, correct? And then there will be a get part and a set part. For example, in the get part, what code will we write now? So all of this code starting from this part, okay, let's move this part of the code right over here. Okay, what change will we make in this part? Because now we are already inside the university class. Do we have to say u1.st list? No. So this will become lowercase st list, right? Everybody agrees?
Yes.
Okay, so let's actually add this line as well. Let's add this line also. Okay, and this is the parameter now for our indexer. Okay, so we don't even have to say if st found not equal to null. We will simply say return st found. So it could be null if we did not find it because we initialized it to null, or it could be whatever student that we found, correct? Okay, so once we have moved it over here, then how will the code in our button handler look like? We can simply write a small if statement over here. So our button handler will look like if, okay, first let's go student st equal to u1 of 1, 2, 3, 5, 7, correct? So once we write it like this through the university object, we are providing the indexer. So that means this will trigger our indexer and pass it as the ID, right? Which will end up triggering all this code and either will bring us a student or will bring us null. So then all you have to do is simply say if st not equal to null, then message box.show st.toString, otherwise not found, right?
Yes.
Else message box.show not found. Okay, so in this example, the indexers made our life easy in the sense that even though we are still doing the same searching code, but the caller only worries about this part, okay? Okay, so the caller's life becomes extremely easy. Okay, do we have to write the set part? It's up to you if you do not want the end user to modify, because remember, this is your data, right? So if you wanted only read capability, you will not write the set part over here. But if you wanted to allow somebody to be able to modify the indexer, you can write the set part also, right? Okay. Okay, so now let me give you your next assignment. And okay, so your next assignment will be create a small university application where you can load students by reading student data from the database. Okay, remember last week you guys already learned how to deal with databases, right? So what I'm trying to say is in the constructor over here, rather than hard coding what students do we have, right? So your constructor for the university class, okay, over here you will read data from student database and populate the SD list. Okay? So that will be the, that's what your constructor will do in the university class, right? Okay, so once you have read all the data in the SD list, then you have to provide different indexers. Okay, so for example, to search by ID, by last name, by first name, okay, by score, by average score, average weighted score, or let me say by grade. So if you wanted to know who are all the students who received, let's say, A minus, your indexer will return an array list of all of those students. Okay, so that will be your next assignment. Okay, and by the way, I'm pretty certain that should be doubled. So because we are returning not the two-dimensional array. In this example, we are returning the value at a particular, so if we had written it such like this, but that doesn't make sense that, if you're returning the whole array. So anyway, it has to be double. All right, so now that you guys are experts in indexers, let's take a look at our next topic. Okay, so now we are moving into intermediate level object-oriented programming, and after a couple of weeks we'll cover some advanced topics as well. Okay, so in the intermediate level OOP, okay, first there's an easy topic. Okay, first let me talk about exception handling. Okay, which is a very important part of software development. Any code you write, you should check for proper errors, display messages properly. So that's one of the topics. Then second topic I'll cover with you will be interfaces. Okay, then generics. Okay, and then few advanced topics. Okay, So anyway, exception handling is extremely straightforward in C# compared to Java. Okay, in Java, if a method is so if you in Java, if you wrote some method, right, and if it was going to throw some exception, you have to write a statement throws, you know, IO exception or whatever type of exception you are writing. Otherwise, if you don't write it and you created an exception, it will not let you compile it, right? C# is a little bit flexible in the sense that if a method throws an error or creates an error, you don't have to say this. Okay, you simply write it like a regular method. Whether you create exceptions or do not create exceptions, it's your choice. Okay, but as a good programmer, you should always take care of errors properly. Okay, so anyway, exception handling works like this. Let's say you created some Windows application in a button handler. You were writing some code like this. You were writing int a equal to 5, int b equal to 7, and let's say int a equal to, or int c equal to a divided by b, right? And then suppose you were displaying the result or something like this. Okay, so first of all, keep in mind both in C# and Java, if both the data types that you are doing a division on are integers, it will do an integer division. Okay, what is an integer division? In this case, it will do 5/7, whatever that answer is, 0.7 something, right? Because both of them are integers, it will truncate the decimal part and it will produce an answer of 0. Okay. What if you wanted the answer to be actually a decimal number? Then what do you have to do?
Double.
Okay, so change one of the, it doesn't matter this one or this one, change one of them to double. By the way, will this work? What if I said A divided by B and typecast it to a double? What answer will it produce in C?
0.
It's still 0. Okay? However, if you converted one of them to a double by typecasting it, then what will it produce? Then it will produce the right decimal number, right? So anyway, so now let's pretend once again you were doing something A divided by B, right? This B was being read from a file or was being read from the user input, right? What if this happens to be 0?
Divide by 0.
So then you will get an error message. See, exception is another word for error. Okay, so you'll get an exception saying divide by 0 exception occurred. Okay. So you as a professional software developer, you never want to write a program where depending upon what the user does, it crashes, okay? So this is where the exception handling comes into play. You always have to properly take care of if there's an error condition, put out a message, but not have the application crash. So the solution to that is what we call exception handling. And exception handling has basically a try block. So whatever code you are writing, you enclose it in a try block, okay? Then you put a catch over here. Okay, and it's up to you whether you want to terminate the program or display an error message and keep continuing. So now you can say, for example, messagebox.show ex.message. Okay, so now let me explain how it works. Okay, so the computer will start to execute once it comes to this line over here, right, obviously it runs into an error. Whenever there's a try-catch block involved and the computer runs into an error, what the computer does is, computer creates an error object. Or you can think of it, or you can say exception object. So an error or exception object. So we'll create, think of it like a box. So this is our error or exception object. For example, if this error occurred at line 12, it will store the error occurred at line 12, right? What kind of error occurred? It will store some information. Divide by 0 is the type of error that occurred, right? So anyway, it stores a few more details over here, which I'll show you in a few seconds. Once this error object is created, then what the computer does it does not go to the next line. Okay, so it skips all the next lines and then goes to the first catch statement and checks to see whatever error object we had created or whatever exception object we had created, does the type of that object match this parameter? Okay, now just like Java, exception with a capital E is the base class for all errors. Okay, so remember, a base class reference can point to a derived class object. So no matter what kind of error occurs, it will match to this one. Okay, since this is the base type, it is capable of pointing to no matter what kind of error occurs, regardless of divide by 0, regardless file not found exception, or some other artificial error that you created, right? So we'll match it, and now it will go over here. Remember, whatever error occurs, I said it also stores some information. So this ex.message will let us know there's a divide by 0 occurred. However, the program will continue to run, so it will not crash. Now you can click on the button again and maybe not type in a 0. However, if it's the error is very serious that you don't want the programmer to continue with your application, you can always display an error message, and there's an application class and you can call application.exit and it will terminate the program. But this is optional, okay? Only for a serious error you will close the application. For most errors you will keep continuing, okay? So now there are many different kinds of errors. And each error has a corresponding class associated with it, and the base class of all those errors is called exception. So in the .NET library hierarchy, exception is the base of all errors. Okay, then it's divided into many subcategories. For example, there's an arithmetic exception, okay, which further has divide by 0, okay, and some other exceptions over here. There's somewhere here related to files. There's a file not found exception. Okay, and lots of other exceptions that gradually you'll get better at. Okay, once we write a try and a catch block, okay, okay, suppose you wrote it like this: catch exception. Okay, and then catch. You can write as many catches as you feel like it. You can say catch, let's say divide by 0 exception. DE. Okay, and there could be more catches over here. Okay, so let's pretend somewhere over here you were doing C equal to A divided by B, okay, and B happened to be 0. So what will happen? As I mentioned, the computer will, if B is 0, the computer will create an error object, okay, and then immediately get out, will not execute the next lines, will get out and see which one matches this exception. So will the first catch, will it match the type of error that we created? Yes or no?
Yes.
Yes.
Remember, because exception is the base of everything, right?
Yes.
So it will always match with this one. Okay, and the rule is that only one catch is executed. So even if you had many catches, it will skip all the rest of those. Okay, so it matches to this one, correct? And so it will not execute whatever we said in the catch divide by 0. So in this example, will this ever execute?
No.
And the answer is it will execute, it will never execute, right? So for this reason, both in pretty much all languages, Java, C#, C++, okay, the order in which we write catches is important. The lower level class comes first, then the higher level, then the base, and so on, okay? So this is a wrong order. So this code will not even compile, okay? So unless you change it to, so you will have to change it to divide by 0 exception as an example. Okay, and the next one will be the base class exception. Okay, and so on. So now let's take a look. In fact, the divide by 0 error occurred. If the divide by 0 error occurred, computer will get out, look for the first catch. Does it match this one? So it will execute this one, then what will happen? Will it go to the next catch and execute that one?
No.
No, okay? However, after all the catches, you have a couple of other options, okay? And it's same in other languages as well. You could write another block called finally. Okay, so finally is always executed, regardless there's an error or not. So regardless there is an error or not. Okay, so in this example, if we wrote C equal to A divided by B, it will come over here, whatever we said, display the error. So if we simply said over here, message box dot show, let's say, DE dot message. Every exception has a message property, so we can display the message, right? Then suppose in the finally we wrote something like this, message box dot show error handled, or okay, or let me just say okay for right now. As we go along, we'll put something more meaningful in it, right? So if we run this program, what will happen if B was 0? What kind of output will we get?
Divide by 0.
We'll get divide by 0 exception. Then it will come to the finally and it will say okay. Okay. What if B was not 0? B was, let's say, 2, A was 7.
Okay.
Then what output will we get?
Okay.
So first of all, it will keep going through, execute all of these statements, right? Once it's done, then will it go to the catch?
No.
No, because no error occurred. So because no error occurred after this one, it will go to the finally block and it will print out okay, right? Okay, so to summarize, the order in which we write the catches is important. The lower level class then the higher base, then the base should be there, right? So to give you an example now, suppose A was 7, B was 2, so obviously there's no error over here. Now we try to open a file over here. I haven't shown you how to process files, but let's pretend our code tried to open a file for reading. And let's pretend file does not exist. Okay, we are trying to read from a file that doesn't even exist. So what will happen? An error will be created, which is of type file not found exception. Okay, so that's the error that will be generated. So suppose that got generated over here. So now will the computer go and execute the next few lines?
No.
No, it will skip. And it will try to see which one matches to, which catch matches to the type of error that was created. Does file not found exception match to divide by 0 exception? No, so we'll skip this catch. Okay, now we'll come to the next catch. Next catch is just the base class exception. So will it match to this one?
Yes.
Yes, it will match to this one, so whatever we say over here will be executed, right? What if we, our next one was, let's say, arithmetic exception. Instead of base class exception, we wrote arithmetic exception. Now what will happen if we try to open a file that doesn't exist?
The system will
Still
crash.
it will throw.
Doesn't find anyone.
It doesn't match this one, it doesn't match this one. Now your program will crash saying unhandled exception occurred in your program. Okay, so that's why as a guideline, as a minimum, you should always have one of the catches, which is the base class, so that no matter what kind of error that occurs, is handled by the base class exception. Okay. There is actually one kind of exception which is not even handled by the base class exception. Once we come to that part, I will show you which one and then how to handle that one, right? But anyway, for right now, either just put the base class exception, but sometimes we want to get more detail about the error. So we do put more than one kind of exception so that we can get precise information about why that error occurred, right? Okay, so now let's pretend we were writing some application. We created a class called student. Okay, with all the 5 fields, everyone has a get and a set part. Okay, then we write some method over here, public string, let's say compute grade. Okay, so from now on, anytime you write a function, okay, a method I mean, unless it's just one line of code, but even in that case, it's always a good practice to surround that code with the try and catch. Okay, so the proper way to write the student class will be, you'll write a try, and whatever code we wrote for computing the grade, okay, and then you will say catch exception EX. Okay, so the next question is, what should we do if we run into an error? Okay, what should we do in the catch part? Should we always write something like this, message box.show ex.message? Should we always write something like this?
No.
Okay, and the answer is no. Okay, why not? Because if you were using this class let's say in a Windows application, okay, where the message box does make sense, then probably it's okay. But what if you were using the student class in your web server, in a web application, and this code is running inside the web server, okay? So now remember, somebody will connect through a browser to your web server. This code is running not in the same machine as the client, but in the web server, which is a totally different machine somewhere far away from you, okay? So even if you popped up a message, where will it pop up? In the web server. The client will never see it, okay? So it's a bad idea if you are creating a class, and that class is a pure code class. It has nothing to do with a user interface. Do not display any error messages, okay? So the proper thing to do in that case will be, okay, log the error message. So you can log it into a database, or later on I'll show you professional logging softwares, so where we can log it into a log file, so that later on we can examine it and recover the error. Okay, so we log it, but is that the only thing we should do, log it in the log file? See, somehow we have to let the user know there's an error that occurred. Otherwise, user will think, oh, everything is fine. But the users will see something blank, okay? So we can't leave, just simply log it, right? So in that case, what we do is, we, in plain English first, send error to the caller of this code. Okay, how do we send the same, send this error, whoever called this compute grade? Okay, so now let's pretend now you were creating a Windows application, and somewhere in your form you had a button, and once you click on the button you were doing something like this: student S1 equal to new student, right? And then S1 dot compute grade, so string gr equal to, okay, so this is what you were doing in something like this, right? Okay, so remember, whatever class we have ultimately will be called from somewhere where there's a user interface involved, okay? So this one triggers this. So now let's send the error back over here, and because it's part of the user interface, it can display it, okay? So how do we send the error back to the caller? There's simple statement called throw. So throw basically means send this error to the caller, whoever called this function. Okay, so in this case, who triggered this function? This one triggered this function, right? So this error will go over here. So think of it this way, as if the error occurs over here. So error is occurring in this line over here. So what happens if there's an error in one of the lines that we are executing? If we did not handle it in a try and catch, what will happen? Your program will crash saying unhandled exception. Okay, so what's the proper way to do it? In the button handler also, put a try and a catch. At a minimum, put the base class exception. Okay, so now let's go and say message box.show. ex.message. So is it okay to show the message here? Because see, this is part of the button handler, right? Which is tied to the form, which is tied to the user interface. So if the code is tied to the user interface, it's okay to show the message, okay? Whether you show it in a message box or you put it in a label over here, either way, you can let the user know some error occurred, okay? So now let's pretend. So sometimes okay, so let's pretend you wrote a few classes in your application. So you wrote a class called grade processing. Okay, and you wrote a few methods over here. Okay, and then there's a class called student. Okay, you have a few fields over here. You have the compute grade method over here. So pretend this is the compute grade. And suppose over here one of these is assign grades. And one of this method is print grades to a file. Okay, and let's pretend the code in this assign grades calls the compute grade over here, receives the whatever the reply is, right? So this is, and then this is our form 1. So this is our class corresponding to our form. Okay, so somewhere in our form 1 we have a, let's say, a button handler. Okay, so this button handler creates one object of this class, calls assign grades. Assign grades further inside it calls compute grade, right? Okay, so now how will you write the try and catch in each one of these methods? Okay, so as we discussed, you will enclose all your code over here in a try and a catch, right? And as a minimum, you will do the base class exception, correct? So what will you say over here? Will you pop up a message box?
No.
No. You will send the error back to the caller, right? How do we send the error back to whoever called it?
Throw.
Simply throw. Okay, there's two ways you can send the error back to the caller. One is throw or throw EX. Okay, so or simply throw. What's the difference? I'll talk about it in a second. So anyway, let's pretend we called this one called over here. In one of the lines over here, it ran into an error. So obviously we'll go to the catch part. This throw EX will now send this error, the same error, back to over here. So this will receive an error now. Okay, should we write this in a try and catch also?
Yes.
Yes, every method from now on has to be enclosed in try and catch. And again, at a minimum, you will do catch exception. Okay, so now what should we write in the catch part over here? Should we pop up a message box to display this error?
Throw.
Is this part of the UI, this class? So if it is not related to a user interface, do not display a message, okay? So simply send the error back to whoever called this function. So just simply say throw. Okay, so now this throw will go back over here. And should we write the button handler code in a try and catch? Yes. So you will write this whole thing in a try, catch, exception, EX. And now what should we do in this catch? Is it related to a user interface?
Yes.
Yes. So now you can go and put the message box over here. EX.message. So which error will this be displaying? Where did the error occur? Error occurred in our example somewhere in compute grade. So this is the information we will see over here. Okay. Now sometimes like in this example, this class called this one, this class called this one, ran into an error, it sent the error back over here, error came back over here, right? So if it's 1 or 2 levels, you can easily figure out, because remember, after you see the error, your job as a developer is to go and fix the error. So you need to know where the error occurred, okay? So if it is 1 or 2 levels deep, you can figure it out. What if it is 6 levels down somewhere the error occurred, okay? So whenever the error occurs, it also keeps track of what was the sequence of calls that came to this function, and that's called the stack trace, okay? So you can also look at the stack trace. So stack trace basically gives you sequence of calls that cause the error. So especially for you to be able to fix things, you have to be able to examine the stack trace and see, okay, at line 5 we call this, then line 17 it called this, line 6 the error occurred. So you can go and now see why the error occurred and try to fix it. Okay, now there are a couple of scenarios where, or I should say, there are some errors that are natural, meaning like divide by 0. Or you try to open a file doesn't exist, the system will create that error for us. Okay, but there are errors that we create because they do not make sense according to our business logic. Okay, for example, let's pretend if a student has no grade for test 1. Okay, maybe the student was sick. In that case, we should not assign a grade to the student, okay? We should create an error, invalid data for the student, okay? So in that case, as you can see, what will our code look like in the compute grade? Okay, will look something like this. I remember we were writing it like this, double AVG equal to 0.4 times test 1 plus 0.6 times test 2, right? However, if our business rule is, if one of the scores is 0, create an error message, okay? So before we do this, over here, we will check if test 1 is equal to 0, or test 2 is equal to 0, then now we want to create an error of ourselves, okay? So how do we create an error of ourselves? There are a couple of options. We create an exception class of ourselves, okay? Or we create an object of the base class exception. So we will say throw new exception, okay? 1 test score is missing. Okay, so again, now if we put it in a try and catch block, so the whole thing is in a try and catch, okay, and whatever the next lines are, catch exception, EX, and throw. Okay, so now let's take a look. Let's go through the same scenario. We wanted to assign grades to all the students, then print them to a file. So we start from here. We call the assign grades function, right? So first we call the assign grades function. Okay, so now we are going into a loop, reading all the students either from the database or from a file, whatever. Okay, so then we come across a student where the test score is 0 and 75. Okay, first test is 0, second is 75, right? So as we call the compute grade on it, what will happen? In the very beginning, we have this line. If test 1 equal to 0, so whenever we say throw new exception, as if we are creating our own error message, okay, our own error object. So see, new exception creates an object of the exception class, right? And we are putting a message, one test score is missing. Okay, so anyway, so whenever we say throw new exception, because we created the error of ourselves, will it execute the next line in the try block? No. So we'll get out of the try block and go to the catch. Does this match to a catch? Yes, the base class matches to everything, right? And in this case, this was also a base class object anyway, right? Once we execute the throw, what will it do? Send the same error where? So from here, we went to over here. Then this throw basically brought the error over here, correct? Okay, now because there is an error that occurred as a result of the call to the compute grade, it will not go through the rest of the loop. It will go to the catch, and which is a further throw. That further throw will come over here, and so whichever line made a call over here, because that ran into an error, it will come to the catch, and we will see when our test scores are 0, right?
So why we create the throw new if the base exception accepts everything?
Because see, if our rule is one of the test scores cannot be 0, because we found one of it to be 0, we have to create an artificial error, okay? So to create the artificial error, one option is just create one object of the base class. Or the other option is create your own error class.
If I didn't create it, the base exception will accept it also. It will be matching and will throw the same error out.
Okay, suppose we did not write this. Okay, there's no if statement over here. How will we handle the case that if test 1 or test 2 is 0, an error should occur?
Just to check the value for each test.
Okay, so we check if test 1 equal to 0 or test 2 equal to 0, then what should we do? See, if we leave it like, we cannot put a message box over here because this is a code class, right? So we have to create an error ourselves. How do we create an error? Like I said, two choices. You can create an object of the base class exception yourself. So you will say throw new exception. So anytime you use the word throw, that means you are creating an error. Okay? Throw a new exception and put whatever test 1 or test 2 is 0. So then this line runs and creates an error, so this is what causes it to go over here, then this throw sends it back to the caller. Okay, so two options. Once again, you can create the base class exception object, or the second object, the second solution is?
So rather than like writing throw new exception, we can just throw exception EX there itself. Like we are delegating it over there.
So let's say we simply say throw what?
Throw exception EX.
Throw EX, but there is no EX over
Exception EX.
but that doesn't make any sense. Exception is a base class. See, we throw a real error. It's like saying if I throw this, I'm throwing a marker. If we just say throw exception, it's like exception is nothing. It's just a template. So you have to create an object of it before you can throw it.
Okay. For a real object.
So you have to, so you see, you think of it this way, exception E1 equal to new exception. And then in the constructor, put some error message. And then say throw E1. So now it's a physical entity that you are throwing, right? A shortcut to writing those two lines is, so a shortcut to writing those two lines is simply say throw new exception. And whatever the error message you are throwing. So then you don't have to write two separate lines. Okay. So second solution, like I was saying, is rather than us creating an object of the base class, if you are creating a really professional application and there are many business rules that you needed to properly check and report if there's a violation. So you can create your own exception class. So in fact, in all large organizations, they have a whole set of classes that they create for different error conditions. Okay. For example, just to demonstrate one of those cases, suppose we say class test score exception. Okay, now the rule is, if you're creating your own exception, we inherit it from a class called application exception. Okay. So once we remember in the constructor, see whenever I say, for example, throw new exception in the constructor, what do we specify? Some kind of error message, right? Okay, and the constructors are not inherited in C#. Okay, so if you anytime you inherit something from some other class, make sure you provide your exception, right? So, so first thing you will do is provide our own constructor so that somebody can pass us an error message. So you will say public test score exception. Okay, let's say string message. Okay, now we can delegate the work to okay, so we can delegate the work to base class exception, base MSG, and just leave it blank. So remember, this is called the initializer list. If you have to trigger the base class constructor or any method in the base class, in your constructor, it has to be done before anything else. So just like C++, this will trigger the base class exception. So now, anytime somebody wrote throw new test score exception, they can give us a message which we can store. Okay. Now you can add more details to this. For example, you can say, for example, what was the time of the exception? So you can create a field over here, date time. Let's call it exception time. Okay, sorry, exception time. Okay, and then provide a get and set property over here that somebody can set that time, right? You can provide some kind of a reason, so string additional detail or something. And again, the get set for that. So you can think of as many extra things that you wanted to put over here. So now coming back over here, if you wanted, if test1 or test2 is 0, okay, what will you do over here? You will say test score exception. Test score exception TE equal to new test score exception, and put some kind of invalid whatever, right? And then TE dot exception time. Is that what I called exception time? Yeah, equal to date time dot now. So anyway, you can store all those properties and then simply say throw TE. Okay, so now this will be if you wanted your own custom exception to be thrown. Okay. So anyway, to summarize, error handling is extremely important. So from now on, every method you write, you will enclose it and try and catch. If it is violating any of your own business rules, you may create your own exception class and throw an object of it. Last thing is, if it is a code class, it's not directly tied to a user interface, okay? Then once you catch, you only throw it back to the caller, okay? And I forgot to explain what's the difference between, let's say over here, I did throw EX as opposed to throw. So there are two choices you can do, throw or throw EX. A throw EX blocks the stack trace, meaning it will only tell you error occurred over here. It will not give you all the sequence of calls that made it that far. Okay, so for security reasons, if you didn't want the anybody to know, you will block it out. Okay, but normal practice is, because this is all internal, you are the only responsible for the code, is throw will maintain the full stack trace so that you can, if needed, you can find out all the detail about it, right? Okay, so I'll stop here.
Professor, if we create our own exception, can we still catch it using the base exception?
Yes, because this application exception from which we derived further inherits from the base exception.